everybody. Welcome back for 4.6, second day. Today we're going to start talking about proofs with overlapping triangles. With these, it might be very, very helpful to have colored pencils or something that you can kind of start to kind of highlight. Highlighters would be good, different triangles, okay? So looking at this proof here, they give you certain statements. They give you this triangle over here. You have to kind of really pay attention with these, okay? So I'm going to grab my pencil over here in some different colors. So first of all, they give you the AF is congruent to DE. And that's a given statement up here, okay? And it's also marked on this triangle here. So I'm going to put this is given. And then we know that FE is congruent to FE. That is not given, but FE is right here. And so FE is congruent to FE because that's that reflexive property. It's itself, okay? So I'm going to write reflexive property right here. And it's kind of hard to write on a vertical surface right here. And then AE is congruent to DF. And so that is right here. I'm going to write AE right here is congruent to DF right here. And the reason that is because of overlapping segments property, because we know that AF is congruent to DE. And then this one is the same segment. They overlap together on that congruent segment. That is called overlapping segments property. Okay, overlapping segments. So I'm just overlapping segments. Right here. Okay, so watch out for that. Then we know that AB is congruent to DC right here. And so I'm going to put this right here. We know that AB right here is congruent to DC. Notice I'm going to try to keep my colors the same here, okay? And that is because it is given. It's given right here. AB is congruent to DC. That's given up here. So that's another given statement. And then angle A is congruent to angle D right here, these base angles right here. And that is also given. Okay? And so you'll see the triangle that we're trying to look at right here is this triangle right here. And this triangle right here, okay? And if you look at what we have that's congruent, we have this side here, okay? I'm gonna try to mark that if I can. This side right here. And then, of course, this side right here. Whoops, wrong color. So we have a side, angle, side. And we have a side, an angle, and side. Okay, so we know that those two triangles are then congruent because of our side, angle, side congruence theorem, okay? So these ones are a little bit harder. They don't have quite the structure that just two random triangles have. So they require a little bit more thinking and overlapping and so forth. These other lines in here are just thrown in there to throw you off, okay? All right, so let's go to this one here. This is kind of tricky. So first of all, we want to prove that SRV, so we want to look at these triangles here that we want to show. SRV, this triangle right here, is congruent to TUW. Now this is tricky because we can't really prove those triangles are congruent without proving some other stuff's congruent, okay? So we're going to show that angle SWT, we know that angle SWT right here is congruent, see those markings, and TVS is congruent right there because of those markings. So those are actually given, okay? So that's actually given information right here because they're marked that way, okay? We know the angle WTS, so we look at right here, WTS, this one right here that's marked, and VTS, or VST right here that's marked. Those are also congruent. That's also given. And then ST is congruent to ST, right here. And that is because of reflexive property. Reflexive property. Okay, and so what we have here is we have this triangle right here, and we have this triangle right here. Okay, we have this angle, and we have this side, okay, and then we have right here this angle, and also this side. So we have angle, angle, side congruence. Okay, So right here, these two angles are congruent because of angle side congruence. Okay? Because of that, we know, and I'm going to pull this, I guess, red art mark up here. Because of that, we know that SV, so this side right here, 1, 2, 3, is congruent to TW. 1, 2, 3. Okay? Now that's part of the triangles we want to show are congruent. All right? So I'm actually going to draw this one. We want to show that the triangle SRV, right? This triangle SRV, and that's that leg right there on the SRV. We want to show that one is congruent to, and I'll use purple for the other one here, TUV. Okay, so notice that this hypotenuse right here is congruent to that hypotenuse. We have a leg, so now we just have to show that, okay? So we know that SV is congruent to TW, and that's because of the previous triangle we just proved is congruent. So therefore, those parts are congruent by CPCTC. Okay, we know that SR is congruent to TU because that's already given. That's marked. So that's a given information. We know that SRW right here and TUW are right angles, and that's just definition of right angles because it's marked at the right angles. Okay, and so therefore those two triangles are congruent because of hypotenuse leg. Now this is a pretty involved one. We're not gonna be quizzing you on this kind of a thing, okay? But it's good to be exposed to this and know, can you identify information in here that is congruent? That's the most important thing, okay? All right, so now we're gonna kind of just look at this application a little bit. So a city runs 3 triangular bus routes to various attractions. How can you draw separate triangles for each route? Are any of the routes the same length? And so we have this green stops, goes from the Science Museum to the theater, to the History Museum, to the zoo, Rose Garden, Science Museum, and so forth. Here's our purple route stops, and here's our red stops, okay? So what I would do is I would take a highlighter or a colored pencil and draw each one of these routes. So it goes from, here's my green route in the triangle, here's my purple route, that's kind of like almost like an isosceles triangle, and here's my red route. And then we have all these distances marked for all these, and we can kind of pull those out, add these distances together, and find out what each of these routes look like. And after we do that, this is what they would look like. We'd have this purple route is 3.9 kilometers, 2.9 and 4.4. This is 3.5, 2.1. We could do the Pythagorean theorem right here, but we don't need to. Why? Because we have a hypotenuse that's 3.5 and a leg that's 2.1. We have an hypotenuse that's 3.5 and a leg that's 2.1. So by HL, these two are congruent. And so we know that those two routes are actually the same distance all the way around. We don't need to calculate that third leg with Pythagorean theorem. We already know it's the same distance. Okay. If we wanted to know how long, then we want to do the Pythagorean theorem. Okay. All right. So that's kind of it. Here's our, our summary of our theorems: side, 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 angle, angle, side, HL, theorem, and so forth. And so we just talk about all of our different theorems and so forth. Here's our assignment. Our assignment's in Excel again. Don't forget to attach your work, all of it. This is just like if you were doing a book work. Every single problem should have something on there, even if it's a multiple choice. I want to see your answer on the sheet. Only thing the Excel is going to do is tell you if you're right or wrong. Okay? So get that done, get your work attached, and I will see you on our next Zoom. Thanks a bunch. Bye-bye.